Well, this is the PSSP final exam rehearsal. And here you will find the solution to the exercise for the graphical user interface. Well, first of all, just open MATLAB. I will do the thing with MATLAB 2019B. And the first thing to do is to be sure that the working directory is the one where you have the basic model that concerns the exam statement, and then all the functions connected to the real-time pacer. There's the example, the library, this M file, and this M file. These 4 files will be given with the exam statement. So don't worry about that. You don't need to take care of them with you. So first of all, I will open the simulation model in order to open for the first time the Simulink. Okay, and then I will be focused on the exam statement. Well, as always, we have a model placed in the digital campus, in the virtual campus in Atenea. In this case, it consists in a production process with quality control and reoperation. The resources, okay, it's fantastic. I'm asked to build a graphical user interface according with the following specifications. Well, first of all, the model, basic model.slx, so here we are. This model must be opened by default with the graphical user interface. Okay, so the first thing to do is to call the guide. And then I will start with a blank graphical user interface. And then here I will save as, with some specific name that will be used later on. Let's say that it's a generic name of graphical user interface. Okay, so here the name will be name of graphical user interface. Okay, but here you can put any name you like. Okay, when I save this, as you may remember, I have an associated M file. Remember, here the properties and the buttons and the like, the placements for every object within the graphical user interface. That is the fig file, as you can see here. And remember that here, besides that, with the same name, I have an M file with all the actions that belong to every object in the graphical user interface. Okay, so because I want to open the model, the simulation model, as soon as the graphical user interface opens, then I will go to the beginning of the M file. Here I have the first function, and you will see that here I have the name of my graphical user interface and the opening function. So this is the function that will run by default as the first function as soon as the graphical user interface opens. So I go to the end, and here at the end, just immediately before the next function, I will copy the following: open and the full name of the file, of the simulation model, between quotes, as you can see here. So I just paste this. Okay, if you have any trouble by chance with the Control-C and Control-V key shortcuts for the keyboard, you just need to go to the preferences here at the Home tab, and then go to the keyboard shortcuts and select the Windows default set. Because if Control-C, Control-V are not working, it may be caused by this Emacs default set. So remember, Windows default set, but it should work by default. Okay, so I have pasted this open basic model.slx. Now I will check that everything works, so I will run this. I go to the editor tab and run. And as you can see, the graphical user interface opens at the same time the basic model. Okay, so I will close both and go to the second point. A push button that quits both the graphical user interface and the model. Okay, so I go to the graphical user interface. Here I will place a push button, let's say here. And this push button, double click on it for the properties, the property inspector, as you can see here. And here the string, it will be quit. Okay, let's, for example, put just a red color, something like that. Okay, let's say, okay, quit this orange one, the orange one. Here I have. And then I want this button to close both the simulation model and the graphical user interface. So right click, view callbacks, I will go to the callback, and this is the function that will run every time the user just pushes this button. Okay, so I will go here, and then as you can see, delete. This is the name of the graphical user interface. Forget about the file extension, forget about the quotes. There are no quotes here. Okay, so I will copy this, and this closes the graphical user interface. Then here, BD close closes the model. As you can see, it's the full name with the extension and between quotes. So I will copy both lines. These are only comments, okay? So I will copy this. I will paste into the callback function, right? Fine, here we are. So now I will check this, just run or F5 if you want, as you can see, save and run or F5, so it's shorter F5. And then if I click on the quit, both are closed. So it seems that it works fine. Okay, so step 3, a pop-up menu that specifies the number of available workers from 2 to 4. Okay, let's have a look first at the model. Let's go to the simulation model here. And where are the workers? As you can see here, the workers are a resource, a human resource. So I will double click here, and the name of the variable is number of workers. As you can see, the variable is named with a camel case. Remember, uppercase, lowercase, uppercase, lowercase, for every word in the name. Okay, number of workers. Okay, so now I will go here, and then just because I need a pop-up menu, I go to the graphical user interface, and I will take a pop-up menu. As you can see, it's here, pop-up menu, and then I will place the pop-up menu here. Okay, I double click and I go to the string property. As you can see here, I can change the text, but I will click in this button, right? If I click here, it appears a new window here. Just set the number of workers. And then here, 2, 3, and 4, because it's between 2 and 4. And they must be integer numbers, right? So 2.5 is not possible, for example. Okay, so now this way, if I run this, I will do this, okay, smaller. If I run this, you will see that I can select any of them, but nothing happens, okay? Because there is no callback yet. Okay, I will quit, and then I will go here, and I will go to the callback. So the action that is associated to this pop-up menu. Okay, go to the callback, and then here at the callback, well, let's follow. Remember, these instructions in red color are the solution of the exam. Okay, so the statement is only this in black and white or black and gray. Okay, so the red is the answer. Okay, so then the number of workers will be the value that the user has chosen. Let's say that the user chooses the second line, 2. So the value returned will be 2. But it's not a 2 because here I have a number 2. It's because it's the second position. You will see. I will copy this line, this comment, and then here I will delete the semicolon in order to see the value that is returned here at the comment window, right? So now I run this, and you will see here I have the comment window. So here at the bottom we will see the user choice. If the user chooses 3, the value is 3, as you can see. Here, number of workers is 3. But pay attention, absolutely no assignment has been done in the workspace, okay? Because it's something within a function. So this number of workers cannot be seen outside this function. Is it clear? So if the user chooses 2, 2, but you may think that this is a 2 because here I have a number 2, but that's not true. Because if the user chooses set the number of workers, it will be returned a 1. Why the 1? Because is, as you can see here, if I go to the text, this is the first line, the second line, the third, and the fourth, okay? But in this situation, the second, third, and fourth lines have the same meaning than 2 workers, 3 workers, and 4 workers, okay? So that's why here, if I close that, the value that is returned, if you go to, for example, 4, the value that is returned is the same value that the number of workers. So that's fine, okay, but remember that this value cannot be seen outside this function. So now the next step is to assign this number of workers to the workspace. If I do that, as you can see here, I get the value, and then this value is assigned to some variable called number of workers here at the workspace. For example, if here I put something, this something is the same something here. But the important thing is that the variable that has been assigned to the workspace is number of workers between quotes, right? This is not important because this is only an auxiliary variable within this function, right? Okay, we will run this, and as you will see, let's go here, we will see the workspace. If the user chooses 2, the number of workers is 2, 3, and as you can see, 4. So it's working. Now, these 3 commands in here are not necessary because these 3 commands are just checking if the model is running, running at the time when the user chooses a new worker, a new number of workers value, right? But this is not necessary, okay? Because this updates the simulation model. So now at this moment, forget about that. And we will do the following. We will set to an enabled state the edit text for the next question. You will see. I will copy this, and just after that, I will set an edit text to be enabled. Why? Because you will see here, I will put an edit text, and this edit text will be the answer to the next question. The next question is to build an edit text that specifies the number of orders to be processed, a minimum of 10 and a maximum of 100, right? So number of orders, here, I will just copy this, and this edit text here will be for the string number of orders, right, with the uppercase N, okay. And as you can see, the tag name is edit1, right? That's why here at the previous function, I set handles dot edit1 to be enabled. Why? Because here I will make this go to the enable disabled, right? So this way, when I run this is disabled, so the user cannot do anything with this. And once I have selected the number of workers, then I can put the number of orders. So any value. Now I'm not doing anything with this value, so I will quit. And let's check the exam statement. The number must be a minimum of 10 and a maximum of 100. Okay, so first of all, I will get the string, right? But this is a string, is a character string. So I need to turn this string into a double precision number. And this number will be assigned to something called orders. So I will copy this command, and then I will do the following here. I go to the action, that is the callback, remember? Callback, and here, at the callback, I will set the orders to be the double precision number that has been introduced by the user by means of a character string. So let's check if this is working. So I remove the semicolon at the end, and let's check if this is working. So now something, and here let's say 254. So once I press the enter key, orders are 254, right? Okay, but this number of orders must be greater than 10, greater or equal than 10, or smaller and equal than 100. So that's why I put this condition. If orders are smaller than 10, or this is the logical or operator, or the orders are greater than 100, here a message box. Orders must be between 10 and 100 units. And then the message box, and I wait for the user to click on the OK push button, right? If orders, the number of orders is okay, then I assign to the workspace base a variable called number of entities. Why this variable name? Just because here you will see that the generation of entities, the number of orders, is called number of entities. For obvious reasons, you can change this name, and consequently, you must change this name here, right? But I will stay with this name, the number of entities, so I just copy this condition, right? These flow control commands. So I just, once I have that, don't forget the semicolon for the value not to be shown. And then if orders are smaller than 10 or orders greater than 100, the message, and then number of entities if the value is correct. So I will run this. Let's put this. Let's put 145, that is outside the bounds. So then here the message box appears, and I cannot do anything until I click on the OK. Then let's say 2, for example, outside the bounds. So here the message, and once it is within the bounds, and as you can see here, once it is within the bounds, the value is assigned at the workspace. So 28, because I have typed a 28, right? Okay, so now I have all the values I need for the simulation. So let's continue. Now a push button that runs and stops the model and shows the status by a color code. Green when the model is running, and red when the model is stopped. Okay, so the same button will do two different things, right? And we can do it in three different ways. For example, let's start with the first option, right? Here we can use an auxiliary variable at the base workspace to take control of the model activity. Well, the first thing to do is to create an auxiliary variable in the base workspace, right? We will use that one being associated with the start, stop, push button. So first of all, I will place a start, stop, push button. So here, a push button, right? That will be, let's say, for example, this push button will be, first of all, here, start the model, right? Start the string. The color will be green. So I will choose a green color. And this green could be, for example, set 0, 1, 0, because it's the RGB combination, right? And finally, here it's very important to disable here. So as you can see, the button is disabled by default. So for this push button to be enabled immediately after the number of orders has been set, I will go back to the callback, and in this callback here I will set what handles dot push button to the property enable between quotes and set to on. Let's check this. Number of workers, number of orders. Let's suppose that here I have a 2. So as you can see here, it's a mistake if you set to be enabled the push button 2 here after the condition. So you must make it enabled just if the value of orders is between the bounds, right? It's between boundaries. So this way, here, if I put a number just 9, the value doesn't enable the start button, right? But if I put 15, for example, then it's enabled, right? Okay, so now let's go back to the start button. Remember, I will use some variable here at the workspace that will take control or will tell me if the model is running or stopped, right? So this way, I will go back to, if you remember, the opening function of the graphical user interface, where I have opened the model. I will assign a variable called model running that it's false, right? Because at the beginning, the model is not running, it's just open. So I will copy this, because this command is already present here. You will see, here is the beginning of the file, down the opening function, and here I open the model. Immediately after, I assign this variable, right? Because this variable will be used in the callback of the start stop button, right? Because every time the user clicks on this button, the model running variable must be the opposite than the actual value. So if it's 0, it will be 1. If it's 1, it will be 0. And this can be done by means of the not, the logical not function, because not of 0 is 1 and not of 1 is 0. Then after that, I will assign the variable to the workspace again, because it will be updated, okay, for the next time the user clicks on this button. And then, depending on the new state, just do one of these things. If the model must be running, I set the simulation command start. and then I change the background color in red, and I will set the string to be stop, and the other way around. If the new state, if the user clicks to stop the model, I will stop the model by means of the set param command, and then I will change the color into some light green in here. It could be 0, 1, 0, okay? And then I change the string property of the button into start again. The same than the beginning, right? So I will copy this. So every time the button is pushed, let me copy the end here, okay? So I will go now to the callback, and this callback here, I paste the values. Remember that the green I'm using now is 0, 1, 0, right? So let's check this. Okay, the number of workers is, let's say, 2. The number of others is 98. So now I can start, and we will see that if it works, here the model will be running. So I start. As you can see, the model starts compiling. Then it's running. Okay. And then here, the action is fine. It stops the model. But we have some trouble. Why? Because the string and the color, the background color of this button hasn't changed. So we have some mistake. It's intentional, obviously, to be noticed about what's happening here. Pay attention that I suppose that the tag name is start, stop, push button, but my push button is number 2. So I need to change the tag name here or in the code. So I prefer just to copy this, push button 2, and here in the code, I change the tag name. Can you see the difference, right? And here, I will change the background color into red, the string to stop, and the other situation into green and start. So 3, number of orders 97. I will start, and you will see that now the model runs and it changes the color into red. And at any time, I just click here and the model stops and it changes into the original form, right? Okay, so let's continue. Just trying to do the same thing by means of a different strategy. So I will delete this. We'll delete everything. Okay, I forget about that. And I forget about this variable in the workspace. And I will do the same thing, but with a different strategy. Now I will use the user data structure. So the first thing is to create an auxiliary variable in the user data. So just in the opening function, in a similar way than before, just immediately after the model is opened, I will set the handles, my tag name. Remember, it's not start, stop, push button. It's push button 2 with lowercase, the user data property, and then I will create a variable called model running. So this way, I will copy this command. I will go here. Remember that I'm at the opening function at the beginning, immediately after the model is open, right? And then I create this model running variable. This will not be assigned at the workspace. So this way I can delete this model running here, okay? Because I will not use this anymore. And then I will go to the callback of the button itself, right? And now the action, remember that now is empty. Now the action will be done here. But remember, the tag name is push button 2. So this way here, at the beginning, remember the opening here, it's not this tag name. The tag name must be changed. Now it's fine. So I will go back to the push button to callback, and we will do something similar than before. You remember the not logical function, so it will be the same. I will take the actual value, I will change this by means of the not logical function. So if it's 0, by default at the beginning is 0. You remember? Because here, at the beginning, here, it's 0. Because the model, once it has been open, it's not running, right? But now, here, I will change the status, because if it's 0, it will be not. 0 is a 1, and the other way around, okay? And then the same, the conditions. If the variable tells me that the model must be running, so start, turn this into red, stop, it's the same than before. But now I don't need to take the value from the workspace, because the value is within the handles structure in the graphical user interface. So I will copy this, go back to the code, I will paste this, and remember that this push button to the tag name. This is a common mistake, right? So be careful with the tag names, right? Here and here, fine. So remember that this is 0, 1, 0. Remember that these values must be changed to, okay, so now I will run 387, I'll start, it changes into red, and when I stop, we go back again. So you can use either, okay? But now forget about this. I will show you the third way to do this. So we forget about this. Then we forget also about this assignment, right? At the opening function. And let's have a look at the third choice. We can get the model status in the start-stop button. Every time the button is pushed, I will get the status of the simulation. Then I will compare. If this variable that contains the simulation status is compared string by string with stopped, and it's true that it's stopped, I will start the model, I will turn this into red, stop. So it's very easy, because this way I don't need to use any auxiliary variables. I will copy this. I will go here, nothing to do with the opening function. And then here at the callback of the push button 2, I paste here is push button 2. Here, copy, paste, 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 right? And there is no need to modify anything else. I will run this, and it's easier. It's here. Start, it turns into red, and then, so this is the easiest way. Okay, I will keep this option. And then let's go to the sixth step, right? And as you can see, is the last one in this exam. So several static texts that return the information on how busy are the resources, right? So now the graphical user interface will be informed by the simulation model. So I will go to the simulation model, just open it, and then I will go to modeling, here model settings, model properties. And within these model properties, we go to the callbacks, and in the start function, it's very important, because I have prepared previously this presentation, it's already filled. I will comment every command in here, right? Well, first of all, this is always the same, to set the hidden handles on, right? to show the hidden handles. So this way, the handles of the graphical user interface will be shown, right? Because by default, they are hidden. So thanks to this command, any file outside the graphical user interface will see the handles, right? Okay, so in this model, I want to get some information here. Let's check which information I want. How busy are the resources? How many resources do I have? Well, I have the workers, machine number 1, and machine numbers 2 and 3, because these are the list of resources, right? And as you can see, I have a gain equal to 1 with a value of 1 for every percentage in here. But be careful, this percentage is not strictly a percentage, because this is between 0 and 1, right? Because it's the utilization. Remember the statistics? Average utilization, a number between 0 and 1, right? If I want a percentage, I need to multiply them by 100. Okay, so first of all, I define this 1, 2, 3, and 4 blocks. As you can see here, the model properties, I define the 4 blocks. Can you see? Here, between quotes, the name of the model and the name of the block. The name of the model, the name of the block, and so on. Every block is different. So that's why block 1 till block 4. What's the event? Every time these blocks post any output, this will be the event. And then the listener, so the function that will take these values and will send these values to the graphical user interface, will be update my graphical user interface. This is the name of the function. And then I define the 4 listeners, H1 till H4. Please make the difference. The function is this, at exec event listener, and then first of all is the block, then the event, post the outputs, and the listener is the function update my guide. Okay, so then, okay. And if you need, obviously, for sure, if you need any extra blocks, just define them here. If you need less blocks, just delete. If you need extra listeners, add them here. If you need less listeners, just delete them. So it's very easy. Okay, let's go now to the update my graphical user interface file. It's this. It's already filled, but I'm going to show you what am I doing, right? Well, first of all, this is always the same. var arg out, var arg in, the input arguments, output arguments, equals, be careful that this is a function. This is the name of the function. Update my guide is coherent with the name of the file, okay? And then I define the real-time objects from 1 to 4, because I have 4 values to be shown in the graphical user interface. I get param, what? The name of the model, and the name of the block, the name of the model, name of the block, between quotes, and then the runtime object. And then I get this data here. I turn these numbers in here into a string to be assigned to every object in the graphical user interface. So that's why here, from the real-time object output port, because it has a single output port, there will be no confusion here, but please just use this form. Then I take the data, so this will be a number, real-time object 1, the output port 1, and the data. This is the number that is the output of every gain in here. So this value here, this value here, are the values that I'm taking here. I multiply by 100, as you can see. I round them just to show not real numbers, okay? It will be 37%, not 37.3, for example. And then, as I told you, I turn these numbers into strings to be assigned to the objects within the graphical user interface. And then this string will be assigned to a text, the second string to another text, the third string to another text, and another text. Be careful, because here I find the objects within the graphical user interface with these tag names, right? So let's go now to the graphical user interface, and now we can put static text, right? Here we are. This is static text, and as you can see, is text2, right? So this, by default, it will be just 0, for example, right? And this is text number 2. Then I will copy, paste text number 3, as you can see there at the bottom, copy, paste text number 4, and text number 5. So this way, I will go here, it's not 3, it's 2, 3, 4, and 5, right? These are the tag names that this file will look for, will try to find. And then here I will set this static text, every one of them, the string property, these strings that I got from the simulation model, right? So, okay, I will save this, and I will try to run the original M file, or directly here, I save that, and then I will run this. Number of orders, 74. Then I start, and you will see that here the values are changing as soon as the simulation starts to run, right? Okay, but these numbers have no meaning, so I will stop, and then they become static. I will quit, and I will do something more polite. Let's say, for example, here, this is percentage of use. These are, remember, the workers. So I will go back to the basic model here. Remember that first of all, there are the workers, the machine 1 and machine 2 and 3. So I will close the model. I'll go back here, use workers, right? So now this will be copied, paste, here, paste, here, paste, here. Then this is machine 1, and then here machine 2, and then finally machine 3. Now if you want the quit button here, you can make it just smaller. Then we run this, and now it's more polite. Here I have my graphical user interface. The number of workers, the number of orders, 54, start, and here you will see the percentage as long as the simulation runs. Stop and quit.